Okay, it seems we're live on Twitch. Let's be live on Instagram. Let's check if we're live on Instagram, just to be sure. And it seems we're live on Instagram also. Okay, it seems good for me. Let's add some sound here. Okay, I have the sound also, so no problem. So just a quick message on Twitter to say that we're live directly. So it's November live coding session 3, and I am now go check it out if you want. And it's on. Okay, everything is set up. So yesterday I've made a quick bubble man, which is here. So basically, just quit disturbing. Okay. So basically, basically we just scale up the bubble, and we also add some dithering, some alpha dithering when the bubble disappears, in order to have some quick fade without having to have an alpha shader. But we was stuck on the same problem as the first session, which was the rotation, which seems to be false when we activate it. So basically our problem was when we activate the rotation of the sphere, the normals seems to be mess up, so the lighting is not perfect. So I will try to correct that, and I think I found a way to correct that on the Unity forum. And also from the first session to the second session, we changed the 3D model where we spawn each bubble. We use another 3D model which has less vertices. The main idea was to have a low polygon model in order to sample the vertices, because if we want to get the vertices on a skin mesh during its animation, we need to bake it on CPU side, which is quite heavy. And I thought about a new 3D model. So always it's the same animation, but it's a new 3D model in order to sample the particle, which I've taken from Keijiro Takeshi, from one of its repository. This one is Skin Vertex Modifier, so it was an example he made in order to modify the vertex position and recalculate the normal on a skin mesh with a surface shader, which is quite impressive. But I was interested in the 3D model, which is here. Let me show you. So this is his 3D model he used, and so it's really a low poly man. And why I was interested in this model, it's because there is less polygon in the hand, in the face, and also on the foot, and this was my problem yesterday. Basically, my 3D model, which was here, my dummy, if we remember, here it is. Let's display the wireframe. So my dummy is quite good for the body, but as you can see, the end is pretty subdivided. It's the same for the hair, for nose, and for the foot. And this was my problem, because if I take a random vector in all these vertices, I might result having more vertices in the end on the head and on the foot, because there is more vertices in the in this area. So I've changed the 3D model, and basically I've made the same things as yesterday. So I've downloaded the 3D model from Keijiro Takeshi repository. I've uploaded it into Mixamo, rig it using the Mixamo auto rig system, and I link my working animation. Then re-download the full animation, add it to my Unity, prepare some let me just disable this. Okay, prepare a new scene for today, which is this one, and I add my Keijiro Takeshi model, which look like this. So less and less polygon. Once again, I've retagged everything as yesterday. Ah yes, le petit jazz. Ouais, je me suis dit que coder avec du jazz, ça fait du bien. C'est tout smooth, c'est tout bien, c'est parfait pour coder. Mais du coup, ça veut dire que tu as du son, Hugo, et ça c'est bien. Du coup, pour revenir à mon modèle 3D. So to go back to the 3D model, and go back in English. So the 3D model has less vertices, which is good, and I've retagged everything. You can see the Mixamo rig and the Mixamo mesh. So it's ready to be used, and I think if I click on play, you will see it. We need to wait a little bit because it's baking again. The lighting is baking, so okay, the lighting is generated. Okay, and now I can have more bubble, but also I can run faster, which is here 40 frames per second according Unity, which is quite good. And especially if we consider that I'm also running a stream with OBS Studio, and I'm taking the camera feed from the Kinect. So this is a Kinect, my camera feed, and also taking NDI broadcasting over OBS Studio. So I think if it's not on stream, I will be faster. Bonne partie de jeux de société, Hugo. Je sais pas à quoi vous allez jouer, mais profitez bien. So, it's run faster, and I've also increment a little bit. So, I've an offset of 50 for the vertices, and which give me 82 bubbles, but I can reduce this number in order to get more bubble, which is now 164, and as you can see I'm running at 25 frames per second, and without OBS Studio, without the stream, I will be nearly 30 frames per second, so this is quite good. Okay, going back to 50 because I think it's a good offset, because as I said yesterday, I prefer when I have some gap on the body. It seems to be better. So this was for a quick overview of what we've achieved yesterday. Okay, I prefer to work without the skybox. Okay, so where was I? Yeah, I was thinking about at first trying to correct this problem we have on the rotation. So let me change everything. So I need to create I need to change something in the controller, in the GPU controller. So I will make a new one. Once again, I will simply create new controllers. I don't want to override the previous one in order to keep everything, so let's keep the same naming convention. It's quite a pain in the ass, but changing everything every day, but because I want to keep every step in my coding experiment and having a full file with everything, so it's better. Okay, so my controller is ready, and now I will need to change the GPU mesh controller, and let's say 03, and then activate the rotation, which was here, and we will see our problem. Okay, so now in the inspector I will need to change this controller, so I don't know if I can I cannot change this. So this is the controller 3, I can remove this one, and this is the GPU mesh controller 3 again, and we know everything. So this is 151. I know that I want to use a sphere with a mean scale of 0.1 and 0.5. I know for sure that we have a mat 2 because I haven't changed the material right now. Let's create a random between black and white, but I think I don't use this anymore because we use a ramp. And let's keep the same compute shader for now, just to be sure. Okay, and the scene for today is ready. Okay, so this was the main problem. As you can see, the lighting is really not good, especially because everything rotates correctly, but it seems the normals are not rotating correctly. So first of all, in order to see everything, I think I will just, let's see the lighting. Okay, I will just scale down a little bit my HDRI just to have less lighting in the okay. We can also simply disabling the skybox intensity where it is. So let's say we don't want to have any intensity. Although I changed the lighting, we were using a spotlight and I changed it by directional light in order to keep the ground evenly lighted. So you can see really the shadows are not correct. Some some balls are light correctly, some are not. And as I said at the beginning of the stream, I found here I found a thread on Unity forum saying that the normals are messed up. So this is what we got the last time, so instancing our balls everywhere, our sphere everywhere, so correct. But when we try rotating the sphere, you get this, which is quite what we got. And if I understand correctly, there is another thread about it. So this one is quite a shortcut, and it seems when we're multiplying the Unity object to word, so the word to object, excuse me. So we are computing in our shader the Unity object to word matrix by taking the matrix the transform matrix multiplied by the rotation matrix, which is multiplied by the scale matrix. But it seems the inverse matrix, the Unity word to object, is not correct. And in this forum, they came up with a solution, and let's check if it works. Not sure. Sometimes finding a solution might be more difficult than this, but let's try this. So I need to create a new instance shader, so this is good, and a new vertex one, this is good, and a new matte. Okay, so this matte will be, let go, so this is this one, and we will use this. Okay. So now we can change our materials in the custom, taking this one. So I correctly load my vertex shader, and here we are. So let's add. So we have this object to word, and we need to define the word to object matrix. So we will add this little cute function, which basically take a matrix and create its inverse. So I hope this will correct everything, and now we can simply say here the Unity word to object will be equal to the inverse of our object to word matrix. And let's hope I haven't made any typo in my script, might be good. And let's check, and it didn't work quite now because I haven't changed my materials, so I need to change it here. look like something more correct. Let's check our main light, where it is. Where is the... oh, the light is quite far from our 3D model. Okay, going back to the main light. And yes, it seems pretty correct to me. This would be in full shadow, this would be in full light, and if I change everything, so let's say 0 0, correct, and correct, seems good to me. So let's start by... okay, so this problem is clearly done. Cool. Let's find a way to highlight correctly our 3D models. I kind of like this this lighting. Okay, so I want a little bit on the side. I want to have some shadows, something like that, and we will reactivate the so let's say 30 to this one, and I will reactivate the skybox, so it will be better. So why it was important to do that? It was because if I want to change everything, so let's say a multiplier by 1 and by 1, okay, it was important because now I can change the 3D model and use one with some specific shape, like let's say a box, for example. And if I want to change my 3D model here on the controller by a simple box, I will now have some rotation on it, so this will be good. Let's say in the mesh I want a box, and Shazam, we have a box man, and it's, I hope so, correctly lit. So this was the main problem, and I need to remember that because I started working with GPU instance since few months ago, and I kind of like the way you can have a lot of elements and you can control everything using a compute shader, but sometimes I struggle into the lighting, so I hope I will improve my lighting and rendering game during this November months. Right now I'm focusing this week on the global setup, and maybe this weekend I will make a full stream dedicated to changing the lighting, the effect, having some kind of, I don't know, screen space reflection. I've tried it today, but it's not perfect. So yeah, sometimes I struggle with the lighting, and on the last project I thought the normal of my 3D model was messed up, but I think it's from it comes from the rotation matrix, which may result of the problem. But because the mesh was quite complicated with a lot of different branches and everything, it was a vegetation system, so we didn't see the difference, and the light was quite even, especially using the skybox, so it was not really a problem on this project. But it's quite interesting having this cube man, but I think I don't want to play with a cube man right now. So we have the skybox. Maybe the skybox is a little bit too high, but because we use the same skybox everywhere, I don't think I will change it. But let's try it simply by having the skybox a little with a more exposure. I think I was a little bit too fast in clicking play because it's baking and the bake is on pause, but okay. Going back to 1.5, we will not change it right now. So go back to the sphere. The sphere is good, the lighting is correct. I can delete this one. So the lighting is correct. This was simply this one. So again, I need to link the thread I prefer to link the thread to my code directly because I don't want to lose this useful helper. So let's say I'm rotating the middle, when redefining matrix this is not redefined, which produce an error in the lighting. Okay, so cool. Okay, so the lighting is good. Let's go to the second problem. The second problem we had yesterday was inside the compute shader, I think. So let's duplicate it and again link it to our controller. So where is my compute? My compute is here. Okay. So the compute, so the problem was this one, this kind of new index. So let's try to find a way to explain my problem. The problem was I was thinking about using a random in order to change the position of each element every time it switches its loop. So the main idea was to generate a random per loop, per index, and I calculate the loop number by using this simple division, dividing the time by the max time to a floor number, which gave me 0, 1, 2, 3, 4, 5, and count the number of loop with achieve when we say maybe I want a running time with a maximum of 10, but if it's 12 we have reached 3 loops, etc, etc. But if I remember correctly, it was not working, and we thought that our sphere were basically having the same position first of all, and didn't change its max size, and also didn't change its position. So this was the main problem. Okay, Unity seems to be a little bit slow. I don't know why. There it is. Okay, Unity is okay. So yeah, let's try with that in mind. let's delete this, also this. Okay. Okay. So as you can see, my sphere here. Oh no, it seems to change its position because this is this one. Let's display our simple body. Oh, the code was correct. Okay, the loop was correct. I was wrong. Okay. So I don't need to change this. So what we can do now, let's think about it. Let's disable the generate. Okay. Just right now. I will reactivate it later, but because it's always baking, I've lost a lot of time. Okay. So if this is correct, what can we do today? Maybe we can change the position. Let's define something. So I want to modify its position, and I think I will need to save the position, the original position, for example. I want to have something moving. Right now the bubble are scaling, so what's happened if we still play with the scale, for example, and using some noise just to try. But I think I will definitely go with some bubble moving, maybe in random position, I don't know, but okay, we have the noise here. So what kind of noise do we have in our, so I have some random and I have some noise. Yes, noise. I think I have a curl. Yeah, I have a curl noise. Yeah, I have a curl noise here. Okay, let's try something really quickly. Let's just say that new scale, just to try. It's really not interesting, but let's say it will not be a curl noise, but it will be a noise based on, I don't know, the time, for example. So this is a noise using a vector 3, this is a noise using a vec 2. So yeah, a vec 2 might be interesting, so because I have it. Oh no, let's try the noise with a vec 3. Vec 2, vec 2, vec 3, vec 2. Allez, let's go for a vec 2 because I will use simply as a float 2. I will set the time, and as a second value I will set the index as a float value, and let's try this. I don't need this and this. Okay, Unity is quite quite laggy tonight. Okay, and okay. I'm trying to delete some tabs. Okay. So now we have a bubble, and it's really speed, I know. It's kind of interesting the way it works. Maybe we can work with the bubble, and maybe tomorrow we will try to explore the movement. But so this is the time, which is quite speed. So let's reduce it. And okay. I think we have a problem with the discard, especially because let's remember how we used the discard. The discard, it was using I was using an alpha test, and I was setting into the color, and the color was the norm time. So maybe it will not be now the norm time, but it might be interesting to set it as the new scale. And let's check. Maybe I need to restart Unity. It's quite slow tonight. I don't remember, but maybe the S noise. Oh yeah, I remember the S noise goes. If I remember correctly, the S noise goes from -1 to 1. So maybe I need to remap this. So 05305 to go from 1 to. Okay, and now invert this, because I think it was fading out when the bubble was scaling down. Not quite sure, but you can see on the image we have some kind of strange behavior on the NDI output. Okay, it looks a little bit better, so let's accelerate some things. I think we've lost the dithering, so I will try with less bubble. Okay. As you can see, we definitely lost the... Oh, no, we haven't lost completely the deathling. But maybe we are going too far. So maybe we need to change the alpha test. Yeah. Okay. So if this works, I think okay. So if this is working, I think I will change the... Let me restart Unity because it seems to be a little too... Or maybe I just... No, I didn't make the same mistake as yesterday, so I will just restart Unity. It was a little bit too slow. So we can keep the scaling, but in fact we can keep the norm time, so each time we reach the limit of the time, it's fade out before it's spawning somewhere else. And away. And maybe if the... Yeah, I think this will be interesting. If we have a bubble which spawn because we are in, remember we use noise for the scale. So if we can use the loop, although in order to didn't have the same scale. So index plus loop. Okay. So now we're generating so because every bubble can spawn with a big size at first, maybe we need to during the time spawning the sphere with an alpha, so it will go from alpha 0, alpha 1 and alpha 0 if it's fade out. And remember, we didn't use an alpha, we used a discard. But a way to generate it is to simply create a ping pong, what I call a ping pong time, which is a time going from 1 to 0 to 1. And by doing that, we have a norm time going from 0. So the best way to do that is simply taking the absolute of the norm time multiplied by 2 minus 1. Because norm time multiplied by 2 minus 1 will give us a normalized time going from -1 to 1, and taking the absolute value of that will be getting a value from 1, 0, 1, and we will have this curve without any easing value from now. So if we want to use a eased value, we can simply taking this value and using our easing function. So now we can bind the is to the alpha and use it as our discard value. And let's check if it works. So as you can see, it's fade in, fade out, even if the bubble has a big size or a small size. Now I can reduce my alpha test if I want to have. So if it's 0, you can see it's spawned directly. So if I want an alpha test of 15, I think it was 15 yesterday. So yeah, which is better. You can see how it's look like some splash effect. Okay, but this noise is quite uninteresting, just blub, 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 blub. Not really fun. And yeah, I just said blub, 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 blub because I want to blub, 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 blub. It's really a lot of sound in this stream tonight. Okay, so going back to that, so if I reactivate every bubble, now we have a bubble man. With some bubble, we just splash over the screen, etc., etc. Might be also interesting to use here the so we can maybe change this new scale. So let's say float new scale, and maybe we can change this by limiting our noise from from 0 to the original scale, so we will still get this distortion effect between the bubbles, because some of them are have a max size of 1, some of them have max size of 0, 1, 0, 5, etc., etc. So we will have a less less bigger. I know there is a word in English. Less bigger. It's stupid. But it will not a big bubble man, but with a slower bubble. So a slower bubble man. Slower? No, not the big one. The good one. But again, okay. So here we are. We retrieved our bubble man from yesterday, but now everything is so it's look like a little bit the same, because our man was having just bubble scaling up, then going to another place and scaling up, and now it's quite slow as the bubble just scale. But as I said just a few minutes ago, I think this noise is quite uninteresting, so I will try to change something. So first of all, let's set the speed to 1 just to see how the bubble can react. So it's quite interesting, not perfect, but quite interesting. So maybe we can use something else, and something else will be, so this is the new position, okay, but we have also the actual position. So I don't remember if we took the actual position, but if I remember correctly, let's say the as you can see, I've made a pretty good mistake here, which is the actual scale I've set up as a float tree, as a float, because instead of a float tree, and here again a float instead of a float tree, which is not a problem in the previous iteration, because it's a sphere, so it does the same with height and depth. But if we play with some parallelepipedic shape, it will be completely a mess. So let's correct this one, and now you can see the max scale, which was this, but I didn't use the max scale, and my new scale here is that. Okay, so X, Y, Z. Okay, so a scale, where did I use this? From now I only taking it, I'm only reading it, so now I use it here, but I use in a float 3, so it's good, and the new scale is still a vector. Okay, so let's take the actual position, which we'll call a pose, and this will be a float 3 again, and we will take this matrix and we need to get the correct position into the array, into the double array. So remember, the scale is 0, 1, 1, 1, 2, 0, 0, 1, 1, 1, 2. Okay, and I didn't remember if I'm, let me check, I don't remember if I'm column major or column minor in Unity, but I think I have again an example with it. Some things are hard to remember, especially when it's come to matrices. So assets script, and it was in my negative space SDF compute, and the position is the last column. Okay, so it's 0, 1, 0, 3, 1, 3, 2, 3. Okay, so it's 0, 0, 0, and this 1, 2, 3. Okay. And it might be interesting to change this noise. So let's say float noised, because I don't want to use the same name as my function, and this was, the noise was that. Okay, so it was a simple noise with a 2D input, and I think I want to use a curl noise just to check. It might be interesting to have some kind of curl inside the scale. I haven't used it since a long time. So let's say a pose, and now we need to add this, and let's create a new one with the index plus the loop. And you know what? Let's define the scale after the position, because we can use the new index as a second value here, and now we can use the time as the third value. And I think the noise is also, the curl noise is also from -1 to 1, so that this one might make a good job. Syntax error, token float at kernel. Where did I make a mistake? Forgot this. Okay. It's really too jiggy. let's change some variables. So what happens if I take the time only in the last variables, in the y-axis? So the x and z will be the same. Maybe the position, just the increment is too the curl is not really interesting. If I use only the time. Yeah. We still have some jiggy value. So as you can see, some value are a little bit too jiggy, so let's change it. And maybe we don't need to go from let's keep from we can simply add an increment, in fact, instead of using the O scale. Maybe we can simply take the scale, okay, and adding the noise. So this is the A scale. Okay. Okay, so this is the A scale. Our curl noise is here. So let's say going from 0 to 1. And now I need to change and scale down because it's an increment. And as you can see, everything is scaling up. So we kind of have the same things as we had last time. So let's take now, we take the A pose. Really not an interesting it's not an interesting way to animate our shape. Okay, let's go back to our simple S noise function, which was better. We're using the loop and we're using the new index. Let me just add in the time because the loop changing with an int, so not the best things to do. What happens if we use the SK? Yeah, I think I used too much value. Okay, we will use. I don't want to have a scale of 0, so I will use simply the original case scale by 0, 1, and then I will add our noise. I can also clamp the noise, but and maybe for this one we can also add more bubble because 82 is not enough for this one. And now we can try to change the position. So going back, because I didn't use this, I will try something like that. Okay, and now I can say maybe float 3 to position that this plus the noise of this multiplied by 0, 1, and this will have some kind of movement inside. So imagine something like that. Okay, so as you can see, the bubble is moving, so our noise is not perfect, but let's keep this noise for that. So I will keep the, for the scale, a noise between 0 to 1, and I will use a scale between -1 to 1. Okay, so as you can see now it's moving. It's not perfect and the scale is really on this, so I can use another noise. Maybe for this one a curl noise could be interesting, so let's go back to this. Okay, let's name this noise scale. Noise scale. Okay, I will reactivate, of course, everything. So this is our is time. Okay, this is a second random. I think I use it here, and now I can use another noise. So plot noise pose, which will be equal to curl noise of a pose, which is the actual position, plus simply the actual position, because simply by doing that, because the position will moving, I think it will be enough. As you can see, so it's really moving too fast. I think I will check on another computer that I've made using this. Okay, let's check how I've made this. It was in GLS cells, but just to be sure, this was this, and I've made where it is. Yeah, I think it's this experiment plan drawing. Okay, this is this one. And where is my compute? Def rotate SS fog random palette noise FXR frag using the this is not the same experiment. Okay, and where it is? Just pet waterfall. I don't have that. I thought I have this one. It's called Lilium. Yeah. Ah, it's a visual project. Okay. So in the visual project here, Lilium. Okay, and data. And now not data. Lilium PCL data. And now I can have something like PCL.comp. Okay. And this is one I've used curl noise by I've used this and then I take the position, which is the actual position, then I add next. Okay, multiply by a link. So okay, this was the idea. I was quite close, in fact. Okay. So first of all, I take in the curl noise using a noise scale. So this is this one. I take the actual position. Okay, this is a pose. So let's say float. Okay. So let's take the actual position in the curl noise. Then we add the time. Multiply by 0.0. Multiply by 1. Okay. Then float 3 position is equal to a pose multiply by plus, excuse me, noise position multiply by an increment, so let's say 25. Look like my position, my A pose seems to be false. Not sure. Let's check. Yeah, my actual position is false. Why? This was this one, 0, 1, 0, 2, 0, 3, 0. Check 1, 1, 1, 3, 2, 2. Did I make a mistake by retrieving the position of my sphere? I think not. It was here in my TRS, so this is good. Uh-huh. 0, 1, 2, 3. I thought in a TRS matrix this was the last element, but I'm not sure. But yeah, it was this one. Oh, no. I forgot to change the line here. 1, 2, 1, 2, 3. Of course, I'm taking only the same elements. So this was why I was moving along a false path. So basically it's more like that. A pose is equal to this, and now it might be up, so okay, so now we have it. And because I overwrite everything, so and if I say this, Okay, and everything is going somewhere else. Because it's the curl noise need to return a float 3. So first of all, this is not the same. Okay. Now, as you can see, okay, and now I need to find a way to so as you can see now it's moving. Of course it's going outside, but so maybe we can write remember we have some data here. So an idea was to the main problem is here is I want to how can I say that I want to restart the bubble at another position every n time, for example. So a way to do that might be to simply use the loop. Okay, so this is the a pose. Okay, so basically the a pose is equal to the actual position, or if I'm in the start of another loop, then I will start with a new position on the body. But how can I do that? But I think I still have some data available. So remember, this is x is the index and y seems to be the norm time. So I might be able to set in the z-axis the loop. So if I take the loop, which is this one, okay, so if I say properties id dot y dot x dot data dot z. So if I said this every time I say the loop in this data, but this is not what I want. The main idea will be to get the actual loop. So let's say float a loop will be equal to property.data z. Okay, so now I get the actual loop, and now I can check if a loop is the same loop as the actual one. So if we are on the same loop, then our float tree a pose will be equal to the actual position of my sphere, of my instance. But if it's not the case, which means I just change the loop so I reach the max time, then I can say that my apose will be equal to my new position, which is basically this one, as we had in the previous iteration. And then, because I want to only set the new position for one frame, I will simply say that for the next frame, property.data.z will be equal to loop, which means in the next frame the loop will be equal, and then we will go back to this one. And now we might have our animated system with an identifier here named apose on the scale, of course, because I need to change then the scale will be going after the position. So here, so after we set everything, did I use this? Yeah, I used this one. Okay, and now compute property x. Where did I make a property x? It's properties. I think it's properties. Yeah, it's properties. My time might be a little bit too. So as you can see, it seems to work. So basically is spawn on the body, but it has this loop. So what we may change for the loop, for example, is the time. So in order to be a little bit to change the speed, in fact. So you can see it changed a little bit the way it behaves. If I said that, you can see, so it's quite jiggy now. Okay, so this is I've set up some name in my other script I made on processing. So it was the noise scale and the noise ink. Okay, so let's say float noise scale, which will be equal to 0.1 as previously. So this is the position which will be multiplied by this, and the noise ink, okay, which will be our multiplier here. Maybe this will be a, let's name the vel. It's more accurate because it's look like a velocity, as it's defined the direction, the speed of our new position. And the noise ink might be, let's say, 0.25, and the time, let's divide by 0.25, just 0.5, just to check. And I have a lot of error. Where do I make this error? I think I forgot some. So this is the noise scale, this is the noise ink, this is the vel. Where did I make some mistake? Yeah, I made some mistake. Where I redefined the noise scale here. Yeah, because it's noise. Yeah. We will changing the naming convention later, and of course I need to say this is called this. Okay. Whoa. Whoa. It's quite a speed up. So as you can see, it seemed really to spawn on the same spot, but we might change the noising by multiplying it by the norm time, so it will speed up along the time. So now it's look like we have some bubble man. So if we change the size, because it's a little bit too 0.25 to 0.1, for example, just to have and now we can display the bubble man. Or maybe it's there is too many speed. Okay. Did I increase? Yeah, I increase a little bit. It's interesting to have this, but I definitely need to find a way to bake the shape more quickly, because as you can see it's slowed down. But let's go back. Let's go back to something more and maybe we can just the curl noise is quite interesting, but we can also simply define a purely oriented velocity, which might also be a good way, especially in this experiment. So maybe we can simply define a static velocity just to having the bubble going up. And I have a problem here, which is what? Where did I make a mistake? I made a mistake here. Okay. Forgetting the so now it's also interesting to have this kind of animation, and we can have this plus the noise. So you see, having this. So my idea is to force the bubble to going up. it will be maybe if we increase the shape we will recognize I want to recognize the body, but now it's difficult, so it's more like an art direction problem right now. Because if I disable the 3D models, if anyone on the stream has an idea, I will get it and test it, because I'm not lost, but I'm not sure what I want to go with this, because I cannot have enough bubble. Oh, another way to add some bubble is to multiplying. Yeah, I can maybe add more bubble. Let me explain. So the main problem I think is I don't have enough bubble on the scene, but I can't increase the number of bubble from the mesh, because baking the mesh in real time takes a lot of process, it's heavier and for the CPU, and my frame rate just drops. So maybe I can keep my array list, my list of vertices, of available vertices to spawn the meshes, the instance, so it will be the same process time, but I can adding multiple I cannot say that I can maybe spawn different bubble of different size at the same place. I don't know if it will work. I think it will work, not sure. So let's say I have this, which is the list of vertex count. So this is the max of instance, and let's say max instance from now is not equal to that, and here I have the max instance, but now it will be modulo the count of the list. So I hope, let's cross finger and let's say 500. I hope it will work, not sure, maybe I will have some problem. So yeah, as you can see, more bubble on the road. So if I say 100, and a lot more bubble on the road. So it might not be the solution, especially for our bubble man. But we have this kind of remnant shape. So let's say something like that. So now I have a lot of different shape, and now I can get back to my main size. And I can change the size here in the compute shader. So I was basically scaling the size, etc., but maybe I can change it a little bit differently. So by using a hist2. Okay, so I'm easing the normalize time, and I will say the new scale will be equal to O scale multiplied by this curve. And I need to, of course, inverse the curve, because I need to start at 1 and get 0, just like a real bubble, in fact. Okay. And now we can maybe change the noise scale. Seems good, but okay. It's kind of interesting because I need to change this. The scale is really up directly. So as I inverse the easing function, it inverted inverse the. Oh, it had made an inverse. It had made an inverse of. Real problem in the English tonight. It had made an inverse of the curve. So I had a normal time going from 0 to 1. Then I use a curve in order to slow down. I think it was slow down, yeah, out, yeah. So to slow down, so it was, but I inverse it so it will speed up the time. So now I invert the normal time to having more view. So as you can notice now, we have more time on it. But now maybe I have too many spheres. Remember, at first we had nearly 100, and 100 we had the body quite interesting. And what is interesting also in this system, it's because we take only the position on the vertices, so it's really take a snapshot on the position. So here bubble, here bubble, here bubble, but when the bubble going up, we didn't follow the vertices, so that's why we have this snapshot with an undefined body. So maybe we can, I don't know, change the global time. So the max time was a random between 2 and 4, and maybe we can change the time by maybe, let's say, between 0.5 and 3 seconds. I think it's 3 seconds now. Okay. And if we increase this, okay, so going back to 100, going back to small particles, this is the max time, which was a random between this. Okay, how can we add some randomness? Maybe we can use also this the random from for the noise ink. by simply using an interpolation, a linear interpolation between this speed and maybe this speed by the random value based on the loop and the index to speed up the process. So some are, and now we can maybe increase a little bit the number of particles. Let's try it. Okay, it seems it's back. Okay, maybe we can stop here and work on the art direction. I think tomorrow I will make a retake of the Mixamo rig controller in order to simply pass the list. So baking the mesh will not be a problem anymore because I will not loop over each vertices at runtime. Okay. So let's, as I said, focus on the art direction, which will be, what happens if we spawn a cube right now just to check? Well, the cube system is quite interesting. Maybe we can work with the cube system. But if I want to work with the cube, maybe I can also influence let's say to the -1, -1, just to influence everything to the back like a trail. And maybe we don't want the trail to be too much. Let's say 0, just to have a trail on the z-axis. Let's say we will increase the random to increase the value of our particle system. Let's try. So I might need to scale on this a little bit if I want to get more speed. And then I can change the speed here. Let's say multiply by 1 in order to get the value of 1 plus 3. So I will have a speed from -1 to -3. Okay. This is a big trail. Two was quite enough. Okay. Okay, and now we can retrieve our noise, which give a more beautiful trail. I can also add in more cube. I think I will change the easing for the scale in order to get a really full body of cube and then quickly scaling down. So earlier 2.5 was quite good in order to have this. Okay. But now that we have a lot of, we can change and don't use a cubic but a more, okay, let's say maybe let's go back to our easing cheat sheet. Okay, this was this one. Which one do we want to use? Actually we here not actually right now we in a ease out cubic, which I found out to be not quick enough. So a quartic might be a good job for that, but I think more about an exponential or a quintic. Let's start with the queen. The quintic is here, so let's start by this one. So this is the is2 I used the is2 as a value for the scale here, so it's okay. Did I save my file? Yeah, I saved it. So as you can see, it's not enough. In expo, I think if the exponential did not make it work, I think I will change the time in order to find a new time computation. Yeah, so I think the quintic was quite good, but the main problem did not come from the quintic. The main problem come from my norm time. So I need to compute another time. So my trail lasts from 15 to 8.50 seconds. Okay, no problem. But I will create a new max time. So this is my time SC for scale, which will be again equal by the random, but this time I will try to scale down really quickly, so maybe by half of the time. And now I can create time for scale, and this will be our mod SC, our norm time SC, and our loop SC, which will be equal to max time mod mod SC. Okay, and now we can use this as a scale. So we use the eased for the alpha, so we can still use the eased for the alpha, and we can, this one is again for changing the position, so we cannot change this one. But now we might have end up with a trail changing quickly the size, and I think we need to keep a smaller size. Okay, and I will say this multiplied by 0.9 just to keeping the size between 10% of the original scales to 100%. Okay, and now if I change everything here by maybe 1, and as you can see, yeah, this is the problem. Basically we have a problem, and I know why. I tried to create a new timeline, but this is not the solution, because the timeline will run in loops. So in fact my cube will go from big to small to big to small to big to small all along the first timeline. So no, the time for scale is not that. The time for scale is a remap, in fact, of the norm time. So if I had something to scribble, maybe I will need to add a new camera to show some little sketch. I need a pen. I think the idea was to have this, so I have a time going from 0 to 1, and I want the scale down, maybe going half or a third of the time. So I can use a smooth step function to do these things. let's try this. I'm afraid of the inversion. Maybe because the inversion here, it will be another. It will be the inverse. But let's try this. Norm time SC will be equal to, as I said, okay, it will be equal to a smooth step of the norm time, okay, which will go from 0 to 1 divided by 3, no, to the third of the norm time. Okay, so now I'm remapping, basically I'm remapping the norm time from 0 to 1, from not from 0 to 1, but when it comes to 0, 3, it will achieve the 1. I'm not sure it's like a linear interpolation. I think so. How can I explain the smooth step? Let's check the definition on the OpenGL. Yeah, it's an Hermite interpolation between two values. And now I can use this here. So this is, so now, yes, as you can see, every cube spawn with a big size and then quickly going. So now it's really it's too quick, it's too fast, too quick, too fast. So instead of using 1 divided by 3, I say maybe half of the time. And now this math we can quickly change the alpha test maybe to 0, 0, 5, just to have our cube here. And now the quintic is quite too big for easing value. Let's reduce the number just to check what happened for, let's say, 10 elements. As you can see, it's spawned and then quickly changing the size, so it's quite good. So if we go back to 100 is really not enough. So then 1,000, and 1,000 again is not enough to consider the animation, the working animation. And for this one, maybe it could be more interesting to have some kind of dancing movements or something like that. We also can have 10,000. So I'm quite happy with today's experiment, because let's say 500, because we achieved we achieve at a place where GPU instance is really interesting when you have thousands and thousands of elements, which was not the case yesterday, because we still have this baking problem, but right now we're looping over over the array, and we simply using the modulo spawning a lot of more elements at the same place. Okay, but we will try a way to be more optimized next time. So let's return to our computer. I think for the computer it's enough. I think it's enough, yeah. We have this kind of problem. Let's change. Sometimes all particle disappears and then there is some, yeah. So if I create a difference between on the offset, it might be better. So do we still see the okay? So let's focus. Let's take a quick break of 5 minutes to think about it, and let's keep this one running and think about which design we can apply on it. So yesterday we use yellow and green, and now, and the day before, we use blue. We have this terrazzo texture, which gives some kind of this little it's not artifact, but it's more like a grainy texture, and if we disable this texture, we will not have this one. Okay, something reddish maybe. We might change the color over the time using the shader. We have the non time bound to the Okay, so let's find a texture, maybe going on. I don't have any idea right now, so wood? No, we want color, not wood. Rock, concrete, leather not, metal no, painted metal no, asphalt, marble, why not? Plastic, we might use some, maybe plastic just to have some roughness, a little bit, and maybe we can add some emissive color, so this will change from our something like that, kind of like this one, this plastic. Okay, let's download it. Okay, we have our texture. Let's go back here. And now okay, so this is the texture. Okay, and in the texture, do we have a black and white texture? Yeah, we have the roughness. So I was interested by the roughness specifically. This is the displacement. Maybe we can use it as the color texture right now. Let's try this. You know what? Let's simply add a new shape on it, like a sphere, big one, where we can put this. Try to zoom and to check how it quite good here. I think I kind of like the way the smoothness, the rudeness work. Maybe I can multiply the rudeness here by the, I don't need this one right now, so it was here, so I use the metallic here. Okay, so I use this, and maybe I can multiply the rudeness, so from 0 to 2, just to increase a little bit the rudeness. So it's kind of, as you can see, a little different. Although I think we can use O dot, I think it's emissive, O dot emissive will be equal to this. So we'll have a full emissive color. Oh, invalid subscript emissive. Surface shader emissive. I thought it was emissive. is not emissive. Emission. It was not emissive, it was emission. Okay, and now I need to add a new value here. Instead of the, it will be under this, and it will be instead the glossiness, the I will call it emissive mul. Not a good name, but okay, let's keep it as this one, and let's say float. And now I can go here and simply reduce the emission by 0.0. Emission is quite interesting because sometimes it will give you some kind of subsurface look, so it's kind of interesting. And I will change the ramp, but let's check first of all the ramp. As I said, I was binding the east function, which is the time, and it's clearly okay. So this is the time we bind to the surface shader into the d value, and if I remember correctly, so we already use a value, I don't remember which one, but in the Qt shader we bind a lot of values, so that I thought the R&D was something else. R&D was used in the data, and I thought we used the R&D in a data value, this one, but yeah, it was it. Okay, tac. Yeah, data y. Let's open the vertex shader. What did I bound to this value? O.data equal data. So yeah, I bind a random value. Okay, yes, it was for changing the color. I remember what we made. So let's change it by A, in fact. So this will now be color.a the time. And in fact, disabling this, so and now as you can see, during the time it will spawn for the as the first color, and then going quickly to the blue. We still have some little one which are yellow. I don't really know why, but it might come from the east function. Yeah, I know why. We bind here the east, but it's let's change that. Okay, so basically we are going from yellow to blue to yellow, because the time here in the east function, which is here, is basically going from from 1 to 0 to 1, but what I want to have is not really is when we can we will use the east. Maybe we simply bind the norm time, so we will not have to compute something else. So let's say properties id.x dot data.z, because I didn't use the z right now, would be norm time. So this will be the norm time, and now in the shader I can say in.data.z, because everything is bound. Oh, why? Color.a. What happened? Did I put something in the z value? I don't remember. Oh yeah, I remember. This is the loop I put in the z value here. So I still have one value left, which is the w, and then I can add the data.w here. And now we're going from blue to the rest. Blue to blue. Let's add a curve. So we're going to blue, from blue to yellow. So if we want to go to yellow to blue, we need to inverse the curve. But we now need to. So now it's more beautiful, and we now just need to change our ramp, and we will be finished for tonight. And as I said, I want to have something like something like red to yellow. So I will create a new ramp from that, and I will let me get my ramp. Okay, so in the cloud prod, no, not prod, dev code member, in the asset we have in the texture a ramp. I will take this one just to get the format, in fact, just to keep the same format, and we will just make a gradient. Where is it? Is here. Okay. And as I said, I want to go from some reddish color, something more like that. Okay, and then this one is 0. Okay, 0. Okay. And I want something like a yellow, the beautiful one, something like that. maybe we can go to not the blue. It's like a beautiful orange with two of them. This one will be really smooth, but I'm not sure it will be the best. It might be interesting to start from the blue. Maybe starting from a no, let's keep something really simple. Let's keep this ramp. And this will be our ramp 4, excuse me. Okay, and now we can use this and say Shazam. And now I think we will use, because we didn't use the color here, so maybe in the shader, in order to get more variation on the color value, we can simply, so this is the ruggedness, by multiply this by in.color.rgb, so we'll get some variation. So as you can see, we now have some darker value and some lighter one. So for example, if I set blue as it's a multiplier, you will see it will really change the value here. So let's say, I'm not sure what I'm doing right now, but might be interesting to keep this value. So I'm not quite sure about the I can increment, as you can see, the emissive multiplier if I want to have something. The emissive multiplier really brings some depth to the okay, and right now maybe we can just what happens if we multiply this by, let's say, instead of this, oh, I made a mistake. This was not the one I wanted to multiply. So yeah, okay, it's quite interesting, but no. Okay, I think we've reached. We can change a little bit this by checking. Okay, and let's say, hopla, where are you two? Okay. Something interesting is we have a random value, so maybe we can change a little bit these gradients. By adding some blue, I don't think so. But some greenish value might be interesting. Something like that. So what I want to create here is to simply create a new ramp, and the main idea is using the random value we set in the, I think it's the y-axis, to simply jump between the two area of our ramp and to bring more color difference inside the our shape. So I will save it as the same name, and now, as I said, I can simply create use a random. I have the random, so I can use a lap. So this will be float y uvy, sorry, which will be equal to a lap between 0.25 and 0.75. The end of the stream, I didn't follow on my second screen when the Twitch has crashed for the second time. It seems on Instagram it's still the same. Okay, and Maximilian prefer the blue color. But yeah, I've used the blue on the first day, so I will use the blue. Maybe later this week I will explore some more value, but because now it's only Kamayo, it's only the same pattern of color, but we're just at the beginning. But yeah, we've made everything we want to make, which is adding some movement, creating something new, adding the rotation, etc, etc. So this is a new body interpretation. I'm quite happy with this one, but the color might be not the best one, as Maximilian said. So yeah, see you tomorrow for another stream. I don't have any idea on what we will be doing the next time, but yeah, maybe we will retake the Mixamory controller in order to have a lot more elements on the body, and maybe we can spawn various elements, etc, etc, because I think we have nearly done all the setup here, so we can focus more on the art direction. So thank you all for following this stream, and I hope you like it, and see you tomorrow. Bye.